Welcome to another video in the Formula SAE tutorial series created by SolidWorks. The previous videos have been fairly complicated and getting heavy on analysis, so today we're going to return to something a little simpler, modeling a shock spring. The example part we'll be using is just a basic shock spring, and at the end we'll use the assembly briefly to see how it's used in context. The first step to creating a spring is to make a circular sketch on the top plane. The circle that we create here is going to be the outline for the helix that will then spiral up and create the body of the spring. Place the center of the circle at the origin, and then select the appropriate dimension based on your spring size. Keep in mind that this only defines the center of the helix. You might also find it beneficial to model the inner radius of the spring and also the outer radius of the spring. I'm going to do that here and just set these lines as reference lines. The view you see here is essentially looking at the spring down from the top as just a sketch. The outside and inside are represented by the dotted lines, and the solid line is the center line of the spring. Next, create a helix by going to the Features tab in the Command Manager, selecting Curves, and at the bottom, Helix and Spiral. Select the middle circle to define the helix cross-section. When defining a helix, you'll have several options in order to select based on height, pitch, and revolution. In this case, I'm going to select height and pitch. You'll see why in a few seconds. This is the most logical option and will make the rest of our spring modeling much easier. One thing to notice here is that while this forms a perfect helix, it's actually not the shape of a typical suspension spring. Springs in a suspension system will coil tighter at the top and the bottom and have a variable pitch. This enables them to be cut off and then have a much flatter surface to push against. We could try to model this feature in later, but luckily SolidWorks provides us with some tools built into the helix menu. Over here we can select either constant pitch or variable pitch on the spring. I'll be selecting variable pitch, and then by changing the values I put in here and adding a few more lines, I'll be able to select a very shallow pitch for the bottom and a shallow pitch for the top while having a normal pitch in the entire center portion of the spring. The most important thing to remember after studying the various levels of pitch is that the final height is the height you actually want for your spring. Now that we've created the helical path, the next step is to create a profile at the base of the spring. Next, under Features in the Command Manager, select Swept Boss and Base. For the profile, you want to select the circle at the bottom, and for the path, select the helix. As I said before, many suspension springs are cut off at the top and at the bottom. In order to create these cutoffs, all you need to do is select Revolved Cut. I'll show you how to make the cut along the bottom. All you need to do is create a simple rectangle that goes through the center of the spring on the bottom. Just make sure that one edge of the rectangle goes through the center line of the spring so that we can revolve it for the cut. After performing a revolved cut on the top as well, we've now completed the model of our spring, and also made it much truer to a suspension spring than just a simple helical model. That concludes the modeling portion of this tutorial, but I'd like to focus on one more thing before we're done. You may be thinking that this is a great opportunity to use configurations, because configurations will allow us to change the dimensions of the helix and therefore create different springs for different suspension conditions, such as jounce or rebound, ride height, full bottom out. Unfortunately, SolidWorks and how it represents helixes does not allow us to do this. We cannot change the dimensions of the helix without changing it in every single configuration. It's not a major issue, and the easy solution is just to create a new part file and new spring based on the different conditions the spring might be in. To see how this works in the context of the shock model assembly, I've gone ahead and opened the entire shock model, and as you can see, there is a spring rebound, a spring jounce, and a spring ride height. All I've gone and done is suppressed each spring that I don't need, and then I can go ahead and change the configuration like I normally would for the part. Just to show you here, I have a configuration for full extension, full compression, ride height. That concludes today's video. As always, if you have any comments, questions, or suggestions, please don't hesitate to send me an email at sfaulkner@solidworks.com.